Okay, today's lesson is 7.4, vector in 3D space. So I want to graph this vector here. 1 is the x component, 2 is the y component, and 3 is the z component, right? So if you look at the Cartesian in 3D, this is my y-axis, and this is going to be in a positive direction. And this is going to be my x-axis in positive direction, and here is going to be what? The y-axis in positive direction. 1 is going to be my x, y is 2, and z is 3. So x is 1, so I just mark that here. Y is 2, I mark 2 here, so these 2 points. And here is 3. So first I need to see where is that. At this point I need to go 2 units up. I said this is 1, this is 2, right? If I go 2 units up, I should be there approximately, right? Do you see that? This is kind of 3D space. So my x is 1 again, my y is 2, and okay, my bad. So the z is going to be 3. So that's going to be the point, right? I need to go 3 units up. So that would be the point. Now this one, so x is negative 3. Again, I do the Cartesian vector. They are 90 degrees to each other. So this is y, x. So since the x is negative 3, I need to go at the other side. Continue that line. Negative 3, 1, 2, 3. So this is a negative 3. Y is 2. I'm just finding the intersection between them. So I need to go 1 unit up, right? See that? See, this is 1 unit up. So that would be my point. So 1, 2, negative 3. So x is negative 3, the y is 2, and the z is 1. So you go 1 unit up. So for the last one, which all of this 3 is negative, again I do the Cartesian vector. X is negative 3, 1, 2, 3 there. Y is negative 2, I have to continue that. So 1, 2, I'm just gonna find it, like you have to do parallel here, right? And for this one you have to do parallel to the y-axis. Then you go 1 unit down. So when you go 1 unit down on the z-axis, you have to see this is negative 1. So there is their intersection, right? So you go 1 unit down. So it's going to be the intersection between this negative 3 and negative 2. Then you have to put your z to be negative 1. Kind of there. Yeah, here. Good. So now I want to talk about the magnitude of the vector. As you all know, in the Cartesian vector, again we have a y, we have x, and we have z. Let's say I have a vector that x and y and z is positive. So let's say this is from here to here is the x component. I call it x1, and call it, this one is going to be y1. So when you just do that, and let's say I'm going by z, right? Is z1. At this one I need to go up towards z, right? And that would be my vector. Okay, so let's see, my vector is like that, right? From the origin to that. So this is the x component of my vector. This is going to be my y component of the vector, and that would be z component. Now here is going to be the same as that. Okay, anyway, now what we do, we want to find the magnitude of that. Looking at the triangle in XY plane, I know in this triangle this is going to be 90 degree, and in this triangle, guys, this is going to be 90 degree, right? So it's going to be perpendicular to the XY plane. So from here to here is X, and from here to here is Y, right? Y1. According to the right angle triangle, if I want to find S here, hypotenuse, I call it S. I know S power 2 is going to be X1 power 2 plus Y1 power 2, right? Also, in the other triangle, the one that is, I'm showing that here is 90 degree here. That's going to be my hypotenuse. Let's say I call it U. I know the vector, the magnitude of the vector U power 2 is going to be what? S power 2 plus this one. So because these are the leg of the right angle triangle. S power 2 plus Z1 power 2. I know S power 2 is what? S power 2 is X1 power 2 plus Y1 power 2. So instead of the S power 2, I put X1 power 2 plus Y1 power 2 plus Z1 power 2. So any vector, if you want a magnitude of the any vector, you just need to square the X and square the Y and Z component, and you get it. And you remember in 2D it was just X1 power 2, Y1 power 2, but in 3D we have this 3 component power 2, square root of that. Now let's just quickly do an example. For each vector below, sketch the position vector, write the vector in form of Aij. So okay, in terms of the ijk, the x component is going to be 3i component plus, you can say minus 1j plus 2k. Find the magnitude. It's going to be 3 power 2 plus negative 1 power 2 plus 2 power 2. It's going to be square root of 14. Would be the same thing for this vector. In terms of the ijk, I is negative 2i plus, I don't have a k component because this is 0, so I just have, I don't have a j component, right? It's 0. I just have a k component, so plus k hat. Okay, and you already know how to do it. Let's just do this Cartesian form of that quickly. Since I just have an x to be negative 2, so this is my x-axis, I go negative 2 here. J, I don't have any y component. K is 1, means you just go 1 unit up. So that would be the vector. Now from the origin, I just go to that point. Make sure this is a vector, this is not a point, right? It's going to be from origin to that. You would do the same thing here. Vector u. Make sure when the vector is going to be a like bracket like that. So just drawing that, 3 means x is 3. The y is negative 1. And if I do that, okay, and then it's going to be 2, means you go 2 units up here, so it's like that. This is the point, and then you draw your vector from the origin. This again, this is x, this is y, this is z. Okay, there you go. Now the next one is the scalar multiplication in 3D. So if you multiply, so if your vector has a 3 component, u1, u2, u3 is x component, y component, z component. You want to multiply it by a constant, you do the same thing in 2D, right? So k multiplied by the x component, k multiplied by the y component, and k multiplied by the z component, simply. So this question, find A such that these two vectors are collinear. Collinear means they have the same direction. See that if I multiply this one by 2, I get 6. Right? If I multiply it by 2, I get 2 here. So I have to multiply this one by 2. Therefore, A is what? 2 multiplied by 2, which is 4. So my vector is 2, 4, 6. Is A is equal to 4. So next one, find AB